Good evening, all. You're welcome to the tutorials with Family the Schoolboy. Today, we'll take a look at physics and review our assignment 5. Physics review assignment 5. We have 10 questions. Number 1 says, which of the following quantities is not a vector? A, velocity. B, work. C, force. D, electric field intensity. Alama. What? Work. B. Okay, work is not a vector quantity. Others are vector quantity because they have both magnitude and what? Direction. But work has only what? Magnitude. Am I communicating? Force times what? Distance. It's a joule. So the answer is what? B, work. Number 2. A man walks 1 kilometer due east and then 1 kilometer due north. His displacement is A, 1 kilometer north 15 degrees east. B, root 2 kilometer north 45 degrees east. C, 1 kilometer north 30 degrees east. D, root 2 kilometer north 60 degrees east. Success. What's the answer? Number 2. Come and tell us how you got B. Fast. Explain what you did.
That 1 kilometer due east and then due north.
If this were to be theory, you fail it to hope you know. A vector without vector diagram is nonsense. 3 of us, you must show us your vector diagram. Let's see what you did. Success. What are you doing? You don't know what you are doing. This is not a vector diagram. You say you got to yourself. B. You got B.
This is what I think how to solve it.
Who can solve this? I want someone that will get the vector diagram just from the question. Give us a good sound vector diagram of this, of what happened, before you can resolve.
This one is not now.
Is what? So where did the man start?
North. East.
So how did he go? Describe how the man traveled. For the question.
Okay. The question said a man walked 1 kilometer.
So where did he start from?
Due east. I don't know that one.
You don't know? Are you able to get the answer?
I'm trying to be practical.
Okay. Make sure you are practical. I'm waiting. You said he did what?
He was walking from east.
Okay, he went to east, then came back and go like this. Is that what the question said?
A man walked 1 kilometer due east.
So how were you able to solve it without?
I've always seen this kind of question always.
Okay, thank you. I now understand where you came from. Who can solve it? Who? Come and solve it. Fast. You don't know it.
Yeah, I know that it is what. Something. It's what.
She got the answer, but I just want to. So where did he start from?
Yeah.
He started from where?
East.
Chinwe, come. You can solve this thing. Come fast. Are you serious? Hey. Now wow. But when we did displacement here, I described this on the board. I even use arbitrary values to solve it. If you know you are bearing, you are secondary school bearing, you can solve this thing now. Didn't you do bearing apart from what I taught you here in our last two classes? At least bearing, yes, secondary school bearing, you should be able to do it. Wow. Okay, let us not waste our time. Huh?
Like this now. Yes, no, it's not like this. Like this, the other will come from down to do this.
No, it's not. Now, the question says, a man walks 1 kilometer due east. So let's use you make use of the cardinal points. Now, the man started from a place. You put a cardinal point. This is point A. Assuming this is point A, where the man started his journey. This is north. This is what? South. East and what? West. The question says, a man walks 1 kilometer due east in the east direction. So he started from here and moved to the east 1 kilometer. Let's assume he stops here. He stopped here. Here is what? 1 kilometer. This is point what? B. And then 1 kilometer due north. At this point now, this is the north of this point. This is the what? South. This is the what? East, and this is the what? West. These are another points. North, south, east, and west. At this point now, the man moved 1 kilometer north, due north. So the man started moving due north. Under 1 kilometer, they should be equal. Here and here should be equal. Under what? 1 kilometer. You put a cardinal point here. This is north. This is what? South. South. This is what? West. This is what? East and what? West. This is point C. The man left point A, his point of origin, and moved eastward to point B. From the point B now, he moved what? North of that B, northward, and stop here. This is the man's movement. The question now asks, what is the man's what? Displacement. Remember I told you that displacement gives the shortest. If we are asked to, how do you mean we are asked to calculate the distance covered? Simply do what? 1 plus what? 1, which is what? 2 kilometers. But you are asked displacement. Displacement is the shortest what? Shortest route. Shortest route, this is where he left. His spot of origin. This is his destination. What is the shortest route to this place? To C from A. It's not here. This gives the mass what? Displacement. But the displacement had a distance component and the direction what? Component. That's why it had a magnitude component, and what? Direction what? Component. That's why it is a vector what? Quantity. The magnitude component of this displacement is what you use Pythagoras theorem. That's what she did here. This is you can call it R or anything. This is what because this is a right angle triangle. This is what success used Pythagoras theorem to solve, and she got it as what? Root 2 kilometer. So the magnitude of the displacement is what? Root 2 what? You understood how she got this one, right? Don't you know about Pythagoras theorem? Wow. That is a different topic altogether. There's what you call a right angle triangle. A right angle triangle is a triangle that has 90 degrees here. This is a right angle triangle. In a right angle triangle, the longest side is the what? Hypotenuse. The one that is below this angle here is what? Adjacent. This side opposite to this angle here is what? Opposite. So Pythagoras theorem say that the square Pythagoras theorem state that the square of the hypotenuse of a right angle triangle, the square is equal to what? The square of what? The opposite, which is this side, plus the what? The square of the what? Adjacent, which is this side. This is hypotenuse, opposite, and what? Adjacent. This is what the theorem says. And that's what she used here to find this side, because this is hypotenuse. Am I communicating? Now, if exactly what she did here, because this is 1, 1. So she now got the magnitude of the displacement to be what? Root 2 what? Kilometer. Is it not very short? Very short you get here than running from here to what? Here. This is the magnitude of the word displacement. But displacement is a vector quantity. Displacement is a vector what? Quantity. So what is left now is for us to find the direction. Which direction did the man? From the point of origin now, what is the man's direction? Where he is presently, and distance, and the how far he is from the origin, from where he left. You know, in the displacement, maybe you left here and you arrive here. In displacement, it's not just how far you went. You also want to check the direction to trace exactly where you are. Am I communicating? That's what displacement will tell you. Now, for us to find that particular place the man is, we need to find this angle, theta. We need to find this angle. If you find this angle, we also find the angle alpha here. This angle alpha here will tell you the particular, the man's bearing. Because you remember I told you that you read from the north. Or from where? From where? South. You read from here or like this. You don't read from east to what? South. Or from west to what? South. You either read from south, so you can have south west, south east, north west, and what? North east. This side is, this is east, this is north, this is what? West. Anything that falls here is in south east. Anything that falls here is in north east. Anything that falls here is in north west. Anything that falls here is in what? South west. You don't say west south. It's wrong, because the major poles are north and what? South. Now, from this thing now, where do you think the man lies? Where do you think, with respect to the point of origin, which side do you think the man's present position lies? Is it northeast or northwest or southeast or southwest? Northeast, right? Now, because this is where the man lies. This is the man's position. So it's northeast. But you don't know at which angle is the man at northeast. We need to find that angle. And for us to find that angle, we must find this angle here. From here to here is 90 what? Degrees. So we need to find this angle here. If we find this angle here, we'll subtract it from 90 degrees for us to find what? This angle here. So the man's actual position should be north alpha degree what? East. So we need to find this. So we need to find this what? Alpha. And the man's displacement now completely is what? Root what? 2 kilometer north alpha degrees what? East. That means we need to find this what? Alpha. But we can't find alpha without finding what? This theta. So let's find this theta first. And if we want to find this theta is opposite to this side and adjacent to this what? Side. And this is the what? Hypotenuse. Now, if you now remember, there's what you call SOHCAHTOA. So means sine theta. So means sine what? Theta. O means what? Opposite over what? H is what? Hypotenuse. Are you looking at me, or are you just writing? Are you following what I'm saying? Good. Sine. So ka means cosine. So cos what? Theta is equal to what? A is adjacent over what? Hypotenuse. Then T means tangent. So tan theta is equal to what? Opposite over what? Adjacent. So looking at this now, this is opposite. So tan theta should be what? Tan theta should be what? Opposite, which is 1 kilometer over what? Adjacent, which is what? 1 kilometer. It's 1 kilometer over what? 1 kilometer, which is what? 1. So tan theta is what? 1. If you want to find theta, we do inverse of what? Tan. Inverse of tan. So theta is what? Tan inverse of what? 1. Which is what? 45 degrees. So this theta here is what? 45 degrees. If this theta is 45 degrees, what will now be what? Alpha. Remember I said that from here to here is 90 degrees. Right angled triangle. So if from here to here is 45, so alpha should be what? 90 minus what? 45. So alpha is what? Theta minus 90 minus what? Minus what? Theta, which is 90 minus what? 45, which is what? 45 degrees. So this alpha here is now 45 degrees. So the man's displacement is now what? We replace this alpha with what? 45 degrees. So the man's displacement is what? Root 2 kilometer north, 45 degrees what? East. This is the man's what? Displacement. This will give you exactly how far the man is from where he started and the direction, how you can trace the man, where the man is staying at that point in time. So the man is lying at not 45 degrees east of his original point of what? Point of what? Origin. Does it make sense? Does it make sense? We have to. So this is what success. I don't know how she was able to. I don't even know what she did. She now arrived at this point. If you do this in your TO exam, you zero because you did nothing. You should be able to describe. Vector diagram is the most important thing. If you're able to get a vector diagram properly, you only lifted that triangle from this. If I leave this triangle now, this triangle becomes. See how it will look like. Here is what? A what? B and what? C. This is even having lifted this now, you couldn't even trace your point of origin again. You became confused. So please, in as much as I like what you are doing, but as you do, try as much as possible to find out. That's why I say consult your textbooks. Most of the things you see online or past questions are half-baked. Their intention is just to answer questions. True of us. But if you go through textbooks, you try to do what? Compare. Maybe if it's a topic you are not familiar with, you can now read one or two things in that topic. You have to understand where their answers are coming from, where whatever they are doing came from. All right, so that is for that number what? For number what? 2. Okay, let's go over to the next one. Number 3. So come here. Come and sit here fast. Number 3. A boy sits in a train moving with uniform speed on a, I say here. Chuma, hope you can see the board from there. Good. A boy sits in a train moving with uniform speed on a straight track. If from his outstretched palm he gently tosses a coin vertically upwards, the coin will fall A. in front of his palm, B. behind his palm, C. beside his palm, D. into his palm. Into his palm. Who knows it? What's the answer? Why? Why do you choose into his palm? Explain. Why not behind his palm? Why not before his palm? Why not after his palm? Why into his palm? Explain. We are listening.
You are facing into his palm.
You answered it now. I say how? Explain what you. Oh, she said that she knew that she wanted to answer it. Are you serious? Are you serious? Tell us why you chose into his palm. I'll keep saying this until you learn it. Don't pick any. In fact, let me tell you the truth. In fact, if I give assignment, even if you've seen it in past question online, try to. If you don't know the reason, don't even circle it. You don't know it. Just say you don't know it. Simple. Than telling me answer there you cannot explain. It doesn't make sense. Because I know this thing is past question, I know, but I don't want to, don't circle it if you don't know it, because I'll ask you question, I'll ask you about it. Yeah, you need to explain it. Favoya, tell us what you think fast.
With uniform speed, and uniform speed is equal distance and it's equal time.
Okay, thank you for that. I like that.
So,
interval, not equal, the interval. Okay, good.
The train is moving and the boy is sit inside a train. So, as stretch his palm, it will fall into his palm.
Why?
Because will I say that the coin that is being tossed vertically upward aligns also with the uniform speed.
Who any Chinaya fast? Your phone. What business has your phone to do with answering questions on the board?
So I did not write the assignment.
Chinwaya.
It's because he did not toss the coin with speed, like he just did it gently. So
Speak like a scientist. Michael, what do you think?
Let's go to his palm. To his palm.
Why?
Because he tossed it gently and he's inside the train, so he said it's moving at a uniform speed. Nothing is pushing the coin back.
You are saying the same thing with Chin. Maya? No idea, child. You know even what is name. Chioma, how far? No idea. Okay, have you heard of relative motion, relative velocity? Let's assume now, if in relative motion now, if somebody is inside a car, if you are inside a car now and the car is moving, if you look at the floor of the car, will even notice that the car is moving, unless there's gallop, two of us. You won't even know unless there's something else that, But do you know why? As you are in that sitting down in that bus, you are moving your speed, and the speed of the vehicle is what? The same thing. There is no relative, there is no how do I put it? Change in speed between you and the what? The vehicle. Am I competing? Your speed is same thing with the speed of the what? Vehicle. But if you try to go back, as you are going back, the vehicle is, let's assume the vehicle is moving with 50 kilometers per hour, as case may be, and you move back inside the vehicle, and you're going back, you fall. True of us, you need to hold something, right? Do you know why? There's a change, between your velocity and the what? Velocity of the what? Car. Am I communicating? Now, someone is sitting down in a vehicle, moving uniform speed, and toss something upward. The speed of the person and the speed of the vehicle are the same thing. The thing will just go up and enter back. But had it been, if he tossed it somewhere like this, it cannot go back, because here is under what? Gravity. True of us. The vertical component and horizontal component, they have this one is different on its own. This one is different on its own. So it will still enter the what? The palm. Am I communicating? Because there is no relative motion between the person that tossed the coin and the vehicle what? Moving. Does it make sense? That's one thing you need to understand. All those at the back, in front, are just there to do what? Confuse you. Does it make sense? So this has to do with what? Relative motion, relative velocity, and what have you. So the answer is actually what? D. Number 3 is what? D. Number 4. What is a vector quantity? Chineke, what is a vector quantity? That has. You don't see that has, not have.
That have both magnitude and direction.
So if you ask now, what is a vector quantity? Is that all you say? Give examples now. Give examples.
Time.
If you are asked what is, you try to say one or two things about true of us about it. Don't just define and keep quiet. Give examples. Time.
Mass.
So time is a vector quantity. Chineke, what I say? Chineke, what I say? Does time have the direction?
No, sir.
Oh yeah.
Okay, sir. Mass, length, acceleration.
So length is a vector quantity. Chineke. So length is a vector quantity. Oh yeah, money is a vector quantity. Who knows vector quantities? Huh?
Vector has magnitude and direction.
If you are asking me as an exam, and you say vector quantity and you start listing mass, length, as vector quantity, you fail it now. I'm saying now. See, there's something I want to understand and see. There's something I want to understand. In as much as, anyway, most of you may not be writing, but even in your exam here in school, you see write ST theory. If somebody asks you what is vector quantity, and you go and start writing vector, but this question like what is, you want to know whether you actually know that thing. I hope you know. Define. You can cram something and define it. True of us. You say what is, they don't know whether you know that thing. Then you now come and you are asked what is vector quantity. Then you define vector quantity and start giving examples of scalar quantity. Do you know it? You don't know it now. True of us. You don't know it. You just cram. You just hear them saying whatever. But you can't explain it. So please note these things. Length, math, these things are. Unless you are misplacing fundamental quantity. Please don't make that mistake, please. Oh, don't make that mistake, please. She will be listening for fundamental quantities for me. So please, who can just tell me, answer this question? What is a vector quantity? I need a comprehensive answer. This is an essay question. It's not OBJ. So answer it like an essay question.
Okay, let me try. Vector quantities are physical quantities which has both magnitude and direction. Example: displacement, force, velocity.
Okay, I think this one is okay. It's okay. It's acceptable. It's acceptable. Okay, the next question says, number 5 says, which of the following is a vector? A, speed. B, distance. C, energy. D, momentum. Chinwe. Momentum. Why do you say so?
Because it's a vector quantity.
How? What makes a vector quantity?
Because it has direction.
What makes momentum a vector quantity? Why is it a vector quantity? Who can tell me why momentum is a vector quantity? Who can tell me? Huh?
Yeah.
It's okay.
I think they have magnitude.
I know, but it's not enough. I need someone that can tell me why is. Start from there, huh? Thank you.
I'm just helping you for the person that will answer.
You are browsing. I look at them why momentum, what makes the vector quantity? Simple. Momentum is a derived quantity that has the mass component and the velocity component. Mass is a scalar quantity, but the velocity is a what? The velocity is a what? Vector what? So with that velocity there, that automatically renders what? Momentum a what? Vector what? Quantity. True of us, because mass is just there. It's the velocity component that dictates the what? That direction, right? So momentum is a what? Vector quantity. But energy, distance, speed, those ones are what? Scalar quantity. Number 6. State the triangle law of vector addition. State the triangle law of vector addition. Even though we have not done it here, but at least I want to teach you how to study ahead. Who did something on it? When I state it, Oloma, fast.
It states that when two vectors are represented as two sides from the triangle, present the magnitude and direction of the resultant vector.
Again.
It states that when two vectors are represented as two sides of the triangle, represents the magnitude and direction of the resultant vector.
Who else? Any other person? Michael. So what did he say?
States that when two vectors are represented as two sides of a triangle, the third side represents the magnitude and direction of the resultant vector, which means that you add the third side is the addition of the other previous.
Anyway, you see it depends on the other direction. Hope you know.
Yes.
Okay, and the magnitude too. Hope you know. Okay, I think it's okay. It's okay. 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 You can simply say that when three forces are in equilibrium, that they can be represented by the three sides of a what? Triangle, both in magnitude and what? Direction. Anyhow you put it, it talks about the same what? Law. All right, thank you. Number 7 says, a boy pulls a nail from the wall with a string tied to the nail. The string is inclined at an angle of 60 degrees to the wall. If the tension in the string is 4 Newton, What is the effective force used in pulling the nail? A. 2 Newton. B. 2 root 3 Newton. C. 4 Newton. D. 4 root 3 Newton. Shioma, what's the answer? You not do it, child. Sussex. Come and solve it. Fine, you try your best, but make sure your best is good enough. Come and solve that thing yourself. Let's see it. If you make a mistake, you will correct it. I keep saying this.
I just read the formula.
Don't write formula. Give us a diagram. Start from there. Try to put whatever information you are given. Try to sketch it. Plot, sketch it. It's very important. Leave formula. Because formula can mess you up one day. If you sketch it, you know exactly how you can go about it. Because this formula is gotten from this. If you know how to sketch it, you are good to go. So don't cram formulas, please. What did you even get at as your answer in the first place? I know you get B, but show us how you got B. I know. We're waiting. See what you do. Clean that board. Read that question again. Try to bring that illustration in that question. Bring it to life. The wall, Let me help you. Please, let's look up. Let's look up so we can. So we do what we have to do without wasting time. Okay, let's see. Sit down. Okay, let's look up, please. The question says, read the question, please. A boy did what? So let's draw the wall first. This is the wall, right? Right? Now, and this is, the nail now. The nail is on the wall. Some part of the nail is here, right? Maybe the head is somewhere out, right? Good. So the boy pulled the nail from where? The wall, right? Continue. With what? A string, Okay, so continue.
The string is lying at an angle of 60 degrees.
To the wall, right? Now, this is the nail. This is the wall, right? String. You know what a string is now. Now, the boy tied the string somewhere here, true or false, and pull it. You want to use the string to pull the wall, to pull the nail from the wall. Remember, practically, the ball is somewhere here, right? This is the wall, right? And the boy is here, dragging the what? With the what? String, right? Now, in reality, even if the boy may be dragging like this, trying to pull it out, right? Now, as he's pulling now, the string now make an angle of 60 degrees inclined to the wall, right? Now, this is the what? The nail. Now, depending on the height of the ball, if the ball is very tall, probably that the angle should be somewhere here. Am I communicating? Yes. True or false? Then if the ball is short, It will be this side. True or false? Are you aware? This is for when the boy is tall. This is when the boy is what? Short. The angle, it will be somewhere here. Here is what? 60 degrees. And here is what? 60 degrees. Are we together? If the boy is tall, if the boy is short, true or false? Now, we'll solve for here, solve for here, see whether we will get the same answer. Now, here, on the string, tension there is what? So the 4 Newton. So here should be the 4 what? Newton. The same thing here they didn't mention whether the boy is short or tall, or whether he used his tool to drag it, or whether he did like this. No, they didn't explain anything. So that's why I'm doing this. I'm also doing what? This. In whatever case, the tension on the string is what? 4 Newton. Now, next question. Continue.
What is the effective force used during the nail?
Now, before we can charging phone. I can charge phone. Now, there's something I want to, before we end, in our next class, we'll talk about resultant force. See, I want to just give a simple illustration of what we mean by resultants. Now, if Chinenye is pushing this table from here, right? Maybe with a force of 20 Newton. She's pushing this table from here. And me, I'm pushing it, for example, now, with a larger force of what? Let's say 40 Newton. Where do you think the table, this chair will move? She's pulling with me, I'm pulling like this. Where will it go? Towards the end. She may even fall, true of us, and the table may even crush, if I can borrow the word crush or fall on her, true of us, because I apply more force. Now, she applied 20 Newton force, right? Me, I apply 40 Newton. But actually, the effective force that made this table to move is what? 20 what? Newton. Not that 20 Newton, my 40 Newton minus her what? 20 Newton. Is so that extra one on top that made it to what? Move. Now let's assume the force she applied is 40 Newton. And me, I applied the same 40 Newton. Would the chair move? It will remain where it is. The resultant force is what? 0. Because my own will cancel her own, it will be 0. The chair will remain. We remain like that until we get tired and go. True or false? Now let's assume that Chinenye, the chair is here. Me, I'm here. Chinenye is here. Two of us are pushing the chair at the same direction. The same chair. And I apply force of 15 Newton. Chinenye also, for example, now apply 60 Newton. And we are pushing the chair, and the chair will now move. What is the resultant force that made the chair to move? It's not that. I applied 50. She applied, let's say, 30. And at the end, we moved it. What is the resultant force made the chair to move? 80. My own plus her own made it to what? Move. Is it clear? Go now. Let's go here now. You know, if this thing was not inclined, maybe the guy is at the same height, or would let's assume that if the guy raises his hand to pull this nail, and the rope is at the point where the nail touch the wall, pierce the wall, is the same height with his hand, he can easily pull it horizontally like this. True of us? Like this. True of us? True or false? The thing will just go, right? Now, the same thing here. Horizontally, it will go, right? Now, for us to know, get the resultant force, right? We just resolve this in this horizontal component. We resolve this, we find this side. Using this angle, we find what? The force here. Using this angle again, we find the what? Force here. Remember our right angle what? Triangle. Remember, this will form what? Right angle what? Triangle. True or false? True or false? This will form what? Right angle what? Triangle. True or false? Now, if you want to find this side of this triangle, this resultant is what is here. Are we together? Are we together? Now, if you want to find this side and find this side, we'll use our what? Soka what? Tool. Now, this angle here is what? 60 degrees. Here should be what? Here is what? Here is what? True or false? 30. Here is what? 60. Here should be what? 30. Now, if you want to find this place now, look up. If you want to find this force here now, it will be this over this. F over this. This is adjacent. This is what? Hypotenuse. So F over 4 Newton is what? Cos what? Cos what? Cos what? Cos what angle? It's cos 30 now. Cos what? 30. Let's look at this place. Let's look at this place. Here is, this place is what? With respect to this angle, here is what? Adjacent, right? And here is what? Here is what? So that means if F over 4 Newton is what? Cos what? Are they something? Are they something? Good. Whether the boy is taller or shorter, the same force that you used to pull it from there, and the force on a normal should act what? Like this. So you need to resolve that inclination to be what? Horizontal. Am I communicating? Now, if we resolve it now, F will become what? Actually, F is now what? 4 what? Cos what? 30. The same thing here. F is what? 4 cos what? 30. 4 Newton cos 30. Now, from our trigonometric distance, instead of using their logging table, sometimes question may be, you see things like sin 30 is half, cos sin 60 is root what? Something like that. Am I communicating? Now, because the options here are not. The options here are in that form, right? So you should be to find what cos 30 is. Basically, cos 30 should give you 0.8. Why say you know? I mean, normal cos 30 should give 0.8660, right? And if you take that root 3 over 2, root 3 is around 1.7777 something. If you divide it by 2, you see you have what? 0.8666 blah. Are we together? So cos 30 is actually what? Root what? 3 over 2. Sine y cos 60 is what? Half. Sine 60 is what? Root 3 over 2. Y sine 30 is what? 1 over what? Just the same way we say that tan 45 is what? 1. Are we together? Now with that now, so cos 30 is what? Root 3 over what? 2. So F is equal to what? 4 Newton cos what? Sorry, times what? Root what? 3 over 2. Are we together? Therefore, f is now equal to 2. Do what? Cancel 2, right? We have 2. So the answer is what? 2 root what? 3 Newton. The same thing here. Here is also what? 2 what? Root 3 what? Newton. So whether the boy is short or tall, you will still get the same what? Thing. Am I the same answer? Are we together? So depending on because they didn't tell us how, whether the boy uses 2 or whether the boy hand could pull it out. They didn't tell us anything. In fact, if the boys, let's assume I'm the boy now. Look at me. Let's assume I'm the boy now, and the nail is here at my level of my hand, 3 of us, and I'll just draw the rope like this. I'll draw the rope like this. What I will use to pull it out from the wall is what? 4 what? 2 what? Root 3 what? Newton. Are we together? Why this was 4 Newton? Because it was inclined at what? At an angle. So you need to resolve it to get the horizontal what? Components. Because the force that will pull it out should act horizontally. Am I communicating? That's why we resolve it to that horizontal component. So we can do what? Pull it out. So the answer is what? 2 what? Root what? 3 Newton. 2 root what? 3 Newton. Yeah, okay. No, ask the question.
Okay, when this formula she used now, when you say application.
See, to tell the truth, listen carefully. To tell the truth, see, once it gets to definition, I don't like using formulas. I draw it in myself. I follow the statement of the question, draw it, see the picture, resolve it from what I'm seeing on the board. Sometimes if you go and say science, you will make mistake. I advocate that you do what? Learn how to do this thing by yourself. Okay? Because some people will go and carry it in their head. You at a point you don't even know when to use cos again and sine again. Some will tell you it's when you want to use horizontal. That's how the question will be twisted. You may see yourself making mistake. So the best thing to, yes, it generally that if you want to get horizontally, but the question can be twisted. So if you know how to draw this diagram, understand the question and sketch it yourself, you know exactly the direction, the force you are looking for. Am I communicating? Good. That's what I advocate from experience. That's what I advocate. Yes, if you do sine 60, it's okay. There is you get, but not in all situation. Are we together? Not in all what situation. Because sine 60 is same thing with cos what? 30. It's not true. So the next one says, number 8 says, an example of a scalar quantity. An example of a scalar quantity is A, velocity, B, weight, C, electric charge, D, acceleration due to gravity. What's the answer? Huh? You said D? No, she said D. Is what? Okay. Acceleration due to gravity. No, it's not D, it's electric charge. It's electric charge.
What is the acceleration?
Okay, sorry. Which answer did you pick? Huh? Call the option. Don't say CD. Is is what?
Acceleration due to gravity.
Are you serious? What direction? Okay, let me now ask a question. What direction does acceleration due to gravity act? In what direction?
Example of scalar. Scalar has no direction now. It's not a vector that has direction.
So you say that. What is your answer, Seth?
This?
So stop call the name of the quantity you called.
Wait now.
I see. Wait now.
Acceleration due to gravity.
Is what? A scalar quantity?
Eh?
No, it's not a scalar quantity.
You know, it is electric charge. Electric charge is the same with electric field.
No.
They're not the same.
Charge different. Field different.
Okay. Where are the states?
Is that what? She'll start blaming you. Why? Why? So you are here and you are communicating. You should come here. So the answer is what? Electric what? Charge. It's not velocity is vector, weight is vector. Electric charge is a scalar quantity. Acceleration due to gravity is a vector what? Quantity. Number 9. Which of the following quantities has the same units as the watts? A. Force times time. B. Force times distance. C. Force times acceleration. D. Force times velocity. What's the answer? Chioma, how did you get it? Come and show us how you got force times velocity. Fast. So how did you get the answer? You just feel like it's the answer. Oloma, what's the answer? Huh?
Force times velocity.
Come here. About food. Who else said for force and velocity? I want someone that knows, not someone that I don't want somebody that know what the answer says. I want the person that knows it to go to the board to tell us how is force times velocity. Huh? Oh, fast. There are a lot to explain. Don't say there are nothing to explain. Take marker.
Watt is power. Yes, power is the rate of work. Yes.
Be it on the board. Clean the board and be it on the board. Is there? Behind the.
This one cannot be close because there's nothing like force times time. I'm not seeing that. Force times time.
Is what? Force times time is what?
Is what?
Work now.
Momentum.
Force times time is what?
Momentum is mv.
What is impulse?
Mass times impulse. Mass times velocity.
Impulse, mass and velocity.
No, it's momentum.
If we are actually momentum and impulse, they have the same units. Impulse is changing momentum, right? But it's actually force times what? Time.
Okay, it's force times.
You don't know?
I don't know.
Know it today.
Like, wow. Then the next one, force times distance is work. So it cannot be the same with downward. I'm just trying to explain the options.
Don't explain. Write it on the
Then the
board.
reason why I say that, according to power, formula for power is force times velocity. Then force, the formula for force is mass times acceleration.
Why? How did you arrive at the power is force times velocity?
Because power is the rate of work done. And okay, I should start.
Now.
Work.
Why do you come out here
Work
in first
done.
place? It's
I
what?
was trying to explain.
Not explain. I say right on the board. Yes.
Work done is equal to force times distance. Jesus. Then force Wait. Yes, now it's rate of work done.
You talk too much.
By this.
Solve on the board.
I'm trying to.
Not explain to me, just be solving. As if she is doing her own here, you are doing your own there. Huh? Why? I don't like that too. It's not good.
That's
I do.
where to arrive at.
You like explaining. Simple, just go straight to the point, you explain it. Now, please, let's not waste our time here, please. Let's not waste our time here. We have that. We are told that the question says, which of the following quantity has the same unit at watt? You should be able to dissect watt first before you know what is in watts. Watt is a unit for what? Power. What is power? Rate at what? At which work? At rate of doing work, right? So that means actually power is what? Work, right? Work over what? Time. What is work by definition? Mathematically, work is what? Force times what? Distance. So work is what? So let's replace work with force times what? Distance. So work is what? Force times what? Distance. All over what? Time. So power is now force times distance over what? Time. We can rearrange this like this. Force times what? Over what? True or false? True or false? This will give us what? So power is what? Force times what? Velocity. So which option is the correct option there? What? D. The answer is what? D. Huh? This is what I expected to say. You will be explaining. You like explaining. Don't explain. Just go to the phone. Give me what I want you to do. So the answer is what? D. Now the last question says, the velocity v of a wave in a stretched string depends on the tension T in the string and the mass per unit length mu of the string, full stop. Obtain an expression for V in terms of T and mu using the method of what? Dimensions. Who can solve this question? Who will try? You say what? Who will solve it? I just solved it, but no long story. Just give me the hit. Just bam, bam, bam. No long story. If I want to explain, you explain. I want you to keep quiet and do it on the board. When you are done, then, if there's need for explanation, I'll ask to explain. I come. Yeah. You want to use yourself? I can use yourself. Give me the marker. Go and use yourself. Come out. Also. Febo, come out. Fast. Shh. Go to the board and do it on the board. Don't say anything. Just go to the board and do it on the board. When you are done, then, if I want you to say, you say. Keep that note. Go to the board.
No, explanation.
No, keep it. Keep that notes. Go to the board and do it on the board. Fast. Don't waste our time. Now take. Don't talk. I'll talk for you. Don't worry. The question says, the velocity v of a wave in a stretched string depends on the tension T in the string.
Wait, sir. Wait.
Okay.
The velocity v of a wave, right? Okay. You can go ahead, sir.
The velocity of v of a wave in a stretched string depends on the tension T in the string
Okay.
and the mass per unit length mu on the string. Micro.
So length is given as what? I think something like
We have mass per unit length. There's no value for length, just mass per unit length. And that mass per unit length is mu. I know. Mu. Micro sign for macro. Yeah, continue.
for the length. I don't know. Okay, we talked about force then.
There's no force here. I didn't mention force.
Let's go.
The velocity v is what? So I should stop. So what do I do? Do you know it? You're there to tell me that the time has gone. Is that what you should be doing than to listen to it, to learn it? Leave that here. Your mind should be here to learn it. Stop counting time for me. The velocity v of a wave in a stretched string depends on the tension T in the string and the mass per unit length mu of the string. Obtain an expression for V in terms of T and mu using the method of dimensions.
What is this dimension, method of dimension stuff?
All right, thank you. Now let's do this so don't waste our time. When we did dimension here, I told you guys that different units from a unit of a particular, for derived quantities, from the formula of those quantities, you can deduce the units, and from the unit you can deduce the what? Dimensions. But in this case now, you want to build using dimension to build up a particular what? Formula. Am I communicating? That's what you are doing here. Now, to do that, I need to clean this board well so we can do it. The board will need to be cleaned well because this is where dimension. In fact, this is what the main thing dimension said. Not that one you just say what is the dimension of meter per second. You tell me L per T, and we jump in that you know the dimension. This is the main importance of what? Dimension. This is the application of what? Dimension. I read the question. The question says what? The question is all over the question. What did the question say? Okay. So there are three things here. We have the velocity, the what? Tension on the string, and the what? Mu, which is the mass per unit what? Length. Now let's go. So we are saying that there's a relationship there that exists between what? This, and this. True or false? But we don't know whether the relationship is direct or what? Inverse. We don't know, right? All we know is that there's a relationship between what? There's a relationship between this and what? This. Are we together? So we simply just say V is what? Because we don't know. If you leave this as this, if you say that this is this, that means you have concluded that the relationship is what? Direct, right? Which you don't even know whether it is direct or what? Or what? Inverse. Because you don't know, you put symbols here, X and Y, to denote that you don't even, because if what is here is positive, that means it's a direct, right? But if what is there is negative, is what? Inverse. Because you don't know whether it's direct or what? Inverse. You just use X and Y. True or false? If what is there is positive, that means V is directly proportional to what? This. But if what is there is negative, is inverse. But we don't know, we use S and Y to do what? Denote the what? That relationship. So we have this to do. We now put this in this form. We now have this in this form. V is proportional to what? T raised to power what? X mu raised to power what? Y. Is it clear? Now you have defined this is a relationship, but we don't know whether it's post, inverse, or direct. This is how you write such relationship, because you don't know whether it is inverse or what? Direct. So our mission is to find this X and Y. If we find this X and Y, we'll come back and substitute it here, and we will get our what? Answer. Now, but for now, to remove this mu, we introduce a what? A constant. So V is what to what? Let it be K. K what? T raised to power S. Mu what? Raised to power what? Y. Mu what? Raised to power what? Y. Now, the next thing we need to do is this. Let's now go. Let's break down these quantities one by one and find out, break it down to their individual dimension and find out what they are, what they contain. This velocity is what? Meter per what? Second. So let's go down to the formula. For the formula, for formula, we move down to the units. For unit, we now go down to the what? Dimension. This is velocity. Formula for velocity is what? Acceleration. Displacement over what? D over what? Time, right? Is equal to K is K. This is what? Tension. Tension is force. True or false? Tension is force. True or false? Force, right? Good. Now, we can now say, what is the nature of the question? Let me know whether we are working with mg or ma. Okay, let's put m what? M what? A. Okay, m what? A. Good. Ma what? Let's put S. Are we to get together? Then mu, we are giving the formula for mu in that question. Mass per what? Good. So mass over what? Length. Good. So this one is what? Mu is what? Mass over what? Length, right? This is force now. Force. Remember, we are just breaking it down to units. Go now. Tension is a force to Newton, right? We are breaking down this Newton now. Is it clear now? So let's change this into their units. Then we'll now go down to the what? Dimension. This is meter per what? Meter per what? Do you agree with me? Do you agree with me? Is equal to what? K. Dot. This is kilogram meter per second squared. True or false? Mass is what? Kilogram. Acceleration is what? Meter per what? Second what? Square. All in what? X. True or false? Now, here is simply meter per. This is mass, right? This is meter, right? Length is in meter. Mass is in kilogram. Length is in what? Meter. So this one is what? Kilogram per what? Per meter. We have what? Kilogram per what? Kilogram per what? Meter. All is for what? Y. We have moved to the formula of these units, these quantities. We have moved to the what? Units. Let's go down to their what? Dimension. This is what? Meter is what? Capital L, right? Yes. We are capital L. This is what? Per what? Per T. True of us? Good. Constant is still constant, okay? Here is kilogram is what? Capital M, right? Capital what? M. Meter is capital L. Second is what? Capital T. So we have per T squared. We have minus 2. Remember all raised to power what? X. Kilogram is what? Kilogram is what? Capital M. This is what? L, right? So we have L, Y. Now, when we now move this dimension now, keep this K is dimensionless. Are we together? Because it will if you use it, everything will cancel out. So this is what? Dimensionless. Because we are moving to dimension now, this K will do what? Disappear. Are we together? So this K, because we are moved to dimension now, this thing has no dimension. It will do what? Go. So we are left with this and this. Now, let us now solve this thing. This statement is saying L per T is equal to, let's expand this. If we expand this, see what we get. M raised to power what? X, right? L raised to power what? X, right? Then what else? T raised to power what? Minus what? 2 what? X. Then dot what? M raised to power what? Y. And what again? L raised to power what? Minus Y. Now let's go. Let's go. We have what now have here is L per T is equal to what? Now let's bring everything together, right? This times this now is what? This is what? L raised to power what? X times what? True or false? We are bringing them together, all the bases together. Times what? L raised to power what? X dot what? Confirmed. So with this now we move. This is equal to what? The same base, right? So it will become M what? Dot minus Y dot what? Are we together? Now, there's something I want us to do here now. We have M here. And we want to bring in M here. What will be here? M raised to power what? Let me know someone that thinks smart. We want M to be here. So at what power can we raise M for to put M here? 0. Confirmed. Because any number raised to power 0 is what? 1. So if you now bring in M now, it becomes what? M raised to power what? 0 L T is equal to what? Plus Y dot what? Dot what? 3 raised to power minus 2s. At this point now, we equate the powers. True or false? True or false? There is base m here. We equate the m, l separately. True or false? That means that actually, what this means is that m raised to power 0 is equal to what? True or false? Y, L, this is 1, both we know. S power 1 is equal to what? S minus 1, 1. Y 3 raised to power minus 1 is equal to what? 3 raised to power minus what? 2s. So we are good to go. This implied, this will cancel what? This, the base will cancel. True or false? This will not become what? 0 is equal to what? S plus 1. Equation what? 1. This will cancel what? 1 is equal to what? S minus 1. Equation what? 2. 2 will cancel 2. You have what? Minus 1 is equal to what? Minus 2s. Equation what? 3. We can simply find s from equation 3. True or false? If you go to find s now, from equation 3 now, let's find s. Here now, from what? Equation what? 3. Minus 1 is equal to what? Minus 2s. That means that x is equal to what? Minus 1 divided by what? Minus 2, which is what? Half. True or false? So x is now what? Half. Let's find what? Y. If x is half, you can go to equation 2. For any of them, and find y. So substitute half for what? Y in what? Equation what? 1. Let's go here. 0 is equal to what? S plus 1. That means anywhere you see x, you put what? Half. That means 0 is equal to what? Half plus what? Y. This means that y is equal to what? 0 minus half, which is what? Minus half. So x is equal to what? Half. Y is equal to what? Minus half. You can test it here. X is half. Y is minus half. So if you want to test it, let's see. Half minus half is what? 1. So it's correct. So x is what? Half. Y is what? Minus half. Now let's go back to our expression here. Where is it? Let's go back to this equation and complete it. Are we together? So this, since x is what? Half. Y is what? Minus half. You can continue here. Since what? X is what? Half. Y is what? Minus half. That implies that V is equal to what? K. T what? Half. Y mu what? Mu what? Minus half. This implies that V is now equal to what? K T what? Half. Remember, any number raised to power minus half is 1 over that number to raised to power what? Half. So this is now equal to what? Mu what? Half. Half. Remember, half is certain as say square root here, which is what? K square root of what? T over what? Square root of what? Mu. So we have square root up in the numerator and the denominator. So they will take one common what? Square root sign. That implies that V is now equal to what? K square root of what? T over what? Mu. This is their relationship. This is their what? Relationship. Have you seen the power of dimension? You've seen how we're able to prove that V. This is actually the formula. It's a formula for tension. Don't worry, when we do sound and other things in a string, I will explain this more. But just this is how application of what? Dimension. So if you know your dimension, you are good to go. So V is K square root of what? T over what? Mu. Y mu is what? Mass per unit what? Length.
When you say you wanted to go before, where did you elevate from?
This is L. It's L. It means H power 1. Three of us. So I put it so you will understand where I got 1 from. L is certain as saying L is power what? 1. Any question? Any question? All right. In the absence of questions, I think we'll end our physics review for today at this point. All right. Thank you very much for your attention. God bless you.